Hello friends, this video on organic chemistry basics part 32 is brought to you by examfear.com. No more fear from exam. Now we'll talk about resonance energy. So what is resonance energy? We have told that more the resonating structure, the more stable is the compound, right? So the difference in the energy, theoretical stability, for example, theoretically if you see, benzene should have X energy, right? But experimentally, it is more stable. Experimentally, if you see benzene, it has X minus K energy. It is less energy, it's more stable. This difference, right, of K is my resonance energy, because this energy K comes from resonance. So if you see, the energy of the actual structure of the molecule is lower than that of canonical structure. This is my actual structure. This is canonical. So if, for example, this has X energy, this will have some X minus K energy, right? This will be low energy, given X and K are positive number. This difference K is my resonance energy, right? So this is the difference you see between these two energies. That is K is my resonance energy, or called resonance stabilization energy, or simple resonance energy. So as I told, more the number of contributing structure, more stable is the compound and more is the resonance energy. You see, more the number of contributing factor, more is the resonance energy. So if it will have 5 resonating structure, it will have, the value of K will be all the more. Correct? So the first feature is that all the resonance structures should have same position of nuclei and same number of unpaired electrons. You see, the position of nuclei is all same. In all these, right, you have 6 carbon in the same positions and hydrogen in the same position. That is the first feature of resonance. The next is all contributing structures. There are contributing structure 1 and 2. They'll have almost same energy. Please note, not exactly same, almost same energy. If it is X, it will be X minus 1 or something. Almost same energy, or X plus minus 1. Now, among the resonance structure, if you see, the one which has more number of covalent bond, all the atoms has complete octet, less separation of positive charge, more dispersal charge, they are more stable. For example, in this case, this oxygen has 1, 2, 3, 4, 5, 6 electrons. This has 8 electrons. So in this, octet is complete, right? This octet is not complete. And if we talk about carbon, this carbon has 1, 2, 3, 4, 5, 6 electrons in carbon, and this carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So if you see, in this carbon, the octet is complete. Here the octet is not complete for carbon. Similarly, for oxygen also, octet is not complete, here complete. So this will be more stable. Correct. Similarly, if you see, the bond distance of the hybrid structure is intermediate of the resonating structure. For example, in benzene, if you see, double bond was my 139, single bond was my 154, right? In the resonating structure, if you see, the bond is between 139 and 154, that is, sorry, this is 134. So this is 139 actually. This is between 134 and 139. Correct? So theoretically it is 134 and 154, but actually if it is, see the real structure, it is 139 picometer. The bond length between CNH. So we talked a lot about resonance, why resonance, how resonance. What is the effect of resonance? What is the effect of resonance? So if you see, the main thing about resonance is it causes displacement of electrons from one part of system to another part, creating centers of low and high electron density. It is a channel through which electron moves. Electron moves in the system, and this is called resonance effect. And there are 2 types of resonance effect. One is the positive resonance effect, the other is the negative resonance effect. In positive resonance effect, the transfer of electron from substituent group to the system take place. And in the negative one, the transfer of electron from system to substituent group take place. Here again, as I told, in inductive effect, think of system first. For example, here I have OH minus. So in this system, this OH minus is adding electron, right? So it will be plus R effect. So in this, now if I take NO2, and in this system, if you see this substituent I have NO2 is going to pull electron, right? So this will subtract electron from the system, so it will have minus R. Correct? So think always from the system perspective. In the system, if a substituent group adds electron, it is plus R. In the system, if substituent group subtracts electron, it is minus R. So plus R group I have is halogens, OH, OR, OCOR, NH2, NHR, NR2 in this group. In minus R I have COH, CHO, CO, CN, and N. Correct? So these are my nitro groups. Cyanide groups, this is my keto groups, aldehyde groups, and this is my acid. Correct? So these are my one with a negative effect. My amines, my alcohols, halogens, all these are my ethers, they are my plus R. So let's take one resonance interaction example. So example, I have NS2 with one lone pair of electron, and let's see how resonance works in this case. So let me draw a benzene. So now in this case, since NH2 group I told is plus R effect, it will give electron to the system. So now if you see in this case, what will happen is this bond should break and it goes here. So this point will get 2 electrons and a negative charge. This guy will get a positive charge. Correct? And 2 lone pair of electron will come and join here and form a bond. And so this guy will get a positive charge. So what will happen is, since 2 electron is coming from this direction, you will get a positive charge, and this forms a bond, and this bond broke and you got a negative charge here with a lone pair of electrons, and the other bonds are intact. This is one structure. The next structure, let me draw. So this will be intact, right? Double bond intact. Now what will happen in this case, let me break this bond and put this both the electrons in this carbon. So what will happen is this carbon will get 2 electron lone pair and a negative charge, right? This guy will get a positive charge, right? This guy is a negative charge and this guy is a positive charge here, right? So this positive and this negative with 2 lone pair will form a bond here. Correct? This is gone now, and this will be intact. So I'll get one more structure like this. The next structure I'll get is something like this. So we have NH2 plus intact here. So this, in this case, this bond will break. This bond will break and go here. So this guy will get 2 electrons and negative charge. But this bond broke. Let this be intact. Now this, since this got a negative charge, this got a positive charge. This negative charge was there, lone pair was there. This negative charge and lone pair will form a bond. So it will go. So you will get structure like this. So these are my 4 structures you will get because of resonance. Correct? Hope you understand this. In this case, one lone pair of electrons, they moved in this direction, formed a bond. Since it moved from here, it got a positive charge here. It was neutral actually, it got a positive charge here and negative charge here, right? Since this carbon will not be able to hold 1, 2, 3, 4, 5, 10 electrons, this also bond broke actually, and this electron moved in this here. You got a negative charge here. This is one structure you got. In next case, this bond broke, right? And this bond broke, it will form a positive charge here, negative charge here. This positive and negative charge, and this is the lone pair, it forms a bond. You got a bond there, and this got a negative charge with a lone pair. In the next structure, this bond broke, this bond broke. So these 2 electrons which was forming the bond came in this carbon only. It got a negative charge and 2 electrons. This guy got a positive charge, actually, if you see, right? This positive charge and this negative charge, and with this 2 electron forms a bond here, and this negative here. These are my 4 resonance effects. Let's take one more example. NO2 minus. NO2 minus, as I told, is a electron withdrawing one. It will withdraw electron. Since oxygen is very electronegative, right? It will withdraw electron toward itself. These bond will break and oxygen will get, it has 4 electrons now, it will get 6 electrons now and a negative charge. Correct? Nitrogen will get a positive charge here. And this will also break this bond actually. It will break this bond to form a double bond here actually. See, what will happen is this will break a bond. It will get a negative charge, it will get a positive charge. This bond will also break a negative charge. Let me draw here actually. This will get a negative charge here with 6 electron. Correct? And this will get a positive charge. Correct? Now I am telling that this bond, if I am breaking this bond, I am breaking. So this will get a negative charge here and will get a positive charge here. Now this negative charge with 2 electrons obviously, right? This negative charge 2 electrons and the positive charge will form a bond here. Correct? So this will form a bond. So this will go and this will go. And rest things will be intact. So I'll get structure like this. Correct? The next structure, what will happen is this bond will break and will go in this carbon. So what will happen is this bond is breaking, this they will get a positive charge, they will negative charge with 2 electrons. So let me draw them. Here. So this bond will break and this guy will get a positive charge, negative charge with 2 electrons and this positive charge. So this positive charge, negative charge, and this is 2 electrons here, right? It will form a bond here. So we have discussed this in the electron displacement. So it will form structure something like this. Correct? Now this bond will break. So if this bond breaks, we get something like this. If this bond breaks, you get a positive charge here, you get a negative charge here with 2 electrons. There's a positive charge already here, there's a bond here, there's a this structure oxygen with 6 electrons in minus. So now this positive charge, this negative charge with 2 electrons will form a bond here. So you'll get something like this. You already had this actually, so you wanted something like this actually. So this is a positive, this was negative with electrons. Now this will form a bond actually. You already had that structure, right? So this will form bond. So we'll get something like this. And this negative and this positive will go. This positive will be there. So we'll get this structure. So we see 1, 2, 3, 4 resonating structure I have. Correct? Let's take my example. Which one is more acidic? See, if I say HCl is more acidic, that means HCl can easily break into H plus and Cl minus ions. So you'll get H plus ions, right? So if it gives H plus ion, that means Cl ions is stable, correct? That's why it gives H plus ions. So the conjugate base, if it is more stable, it is more acidic, correct? So let's find the conjugate base of this. The conjugate base of this will be CH3 O minus, and for this it will be O minus, correct? So now we have to say which one is more stable. So more stable here is more acidic. Hope you understand this. See, Cl minus is more stable, so HCl is more acidic. You see water, if you see, it gives H plus and OH minus, and OH minus is not stable. So water is less acidic, but Cl minus is stable, so it's more acidic. So conjugate base is more stable, that means it is more acidic. So this is all my conjugate base. The one which is more stable is more acidic. So in this case, if you see, due to inductive effect, what will happen is this CH3, so it will give electrons here. So if you see the inductive effect, you think that this is less stable. But now if you see the resonance, there are two resonating structures for this. One is this The other is this. This is resonating structure, and in this case there is no resonance. So since there are resonance here, you can say that due to resonance, this guy is more stable. This guy is more stable. Correct? So this guy, my ethanoic acid is more acidic. So this guy is more acidic. Correct? Since it is more stable, this guy is more acidic. For numericals, we have to draw the resonance structure for C6H5OH, CH3, CH, and C6H5CHO. Let's draw for the first C6H5OH. That is my benzyl alcohol. So I have OH here, and let me draw. This is my starting structure. Right, since OH is a electron giving group, so it will, as you see, 4 electrons here, it will give electrons here. This carbon will not be able to hold some electrons, so it will break in this fashion. So what you will get, the next structure will be what? Next structure will get double bond here, OH with a positive charge because electron moved from here, and here you will get a negative charge, right, with a lone pair of electrons. Correct? And these will stay as it is. In the next case, this bond will break, right, and it will come here in this carbon. It will get a positive charge, this negative charge combined to form a bond here. So let me draw the structure also. So it will be OH with a positive charge. So here these two will form a bond. This will get a lone pair of electrons and negative charge, and this will remain intact. Correct? Now in next scenario, what will happen is this bond will break, right? And this negative charge, this will get a positive charge, will get a negative charge with lone pair of electrons, and these two will form a bond, right? Because it will get positive and will get negative. Or you can see that this moved from here to here, either of these, whatever you want. So this bond will be intact, and here will form a bond. This bond will break. This will become OH plus, and here you will get a lone pair of electrons and negative charge. Now in this case, this electron will travel from here to here. It will break a bond, and it will move the positive charge from there. So it will form something like this action. So if you see, there are so many structures for C6H5OH. Okay. Let's draw the structure of this but2-in-1-L butanol. So this is CH3, CH, double bond CH, COH. Correct. Here this guy will move in this direction. You get a negative charge with a positive charge, and this bond will also break actually. It will go in this direction. In fact, these two electrons will go in this carbon, and this will form a bond actually. So with this, the new structure which you get is, let me draw, CH3, CH single bond, CH double bond C, O minus, and then H, and here you will get a positive charge here, right? Here you will get a positive charge. Correct. So these are my structures I'll be getting. C6H5CHO is benzaldehyde. You can draw a similar structure as I have done for phenol. This phenol, similar structure you can draw for benzaldehyde also. Now let's talk about. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.